zone. We're talking about continuous and discrete from all my options down here. Determine whether each situation represents a discrete or continuous function. The function y equals 30.48x converts from x feet to y centimeters. Yeah, because you can have partial centimeters, partial feet. That's continuous. Besides that, with that kind of a decimal, most of your answers are going to have decimals. The function y equals 3x plus 2 represents the amount of water y in gallons in a tank after x minutes. That's going to be continuous because guess what? You can measure partial minutes, right? 2 minutes, 30 seconds. So yeah, that's continuous. All right, let's look at C. The function y equals 50 minus 3.5x represents the amount of y of money in dollars that you have left after buying x loaves of bread. Can I buy part of a loaf of bread? No. So in this case, this is going to be discrete. All right, the function y equals 10x represents the number of marbles y in x bags. That marble is going to be static. You're not going to have in between. You're not going to have partial bags, right? You're going to have just set bags. So again, this is discrete. Awesome. All right, let's roll. More of that discrete stuff going on. So continuous, discrete, or neither. When I look at this, look, the straight line says continuous, but the steps say discrete. So in this case, that's actually called a step function, and it is neither continuous nor discrete. This one is just one single curve, so that is continuous for h of x. And then our j of x right here, it's just a bunch of points, no lines, it is discrete. One of each. Use the graph to estimate the x and y intercepts of this function and describe where the function is positive and negative. All right, so I'm going to do that without looking at these at all. My x-intercepts are right here, here, and here. So I know that my x-intercepts, I'm going to have 3 of them. So I make 3 of the butts, right? And for an x-intercept, where do we put the dimple on the butt? Well, we know it's 0 at y, so put the dimple on the right cheek. That's just how I think of it. All right. So because of that, where are the values? Well, we have negative 2, 2, and 3. It's that easy. For my y-intercept, well, this is a function, so we know we only have one y-intercept. It's over here. I'm drawing my butt, but the dimple goes on the left cheek, right? And because x is 0 on the y-axis. And so we see it passes through right at about 12, so there we go. I wonder if that eliminates anything right off the bat. So x-intercepts, oh, there's only 2 right here. That's gone. 2, 3, and negative 2. Yeah, this one is possible. 2, 3, negative 2, that's possible. 2, 3, negative 2, that's possible. Okay, so now let's look at when it's positive. And I'm going to use a highlighter to help me. I'll leave these out on the test for anybody that wants them. First come, first serve. So I'm going to do negative in pink. And I'm going to do positive in yellow. Remember, positive is just above the x-axis. Negative is below the x-axis. We're talking about the negative and positive y values. So when is it negative? Well, do they do positive or negative first? Okay, they do positive first. We'll do it in the same order we see them doing it. We do positive. And it's positive when x is in between 2 and negative 2. Remember, we're going to use that x-intercepts really as our boundary points. So when x is less than 2 but greater than negative 2, right? Okay. It's also positive, we see at 3, when x is greater than 3. So any of our x values, 3 and bigger, it's always going up. When is it negative? Well, it's negative when x is less than negative 2, right? When x is less than negative 2, we see it going more negative, and in between 2 and 3, so when x is less than 3 but greater than 2, just a little interval, but it's still there. And let's look at that. So y-intercept, oh, I never checked the y-intercepts. 12, y-intercept. Oh, this one doesn't work. It switched the x and y-intercepts. I didn't even notice that. This one's good. Okay, so we're down to these bottom two. Now let's look at the positive. So when x is between -2 and 2, less than 2, greater than -2, perfect. And when x is greater than 3, okay. It's negative when x is less than -2, and when x is less than 3 and greater than 2. I think this one's right, but let's take a look at the last one to see if there's a reason. Well, I know this one's correct. Let's see why this one's incorrect. So it says when x is less than -2 is when it's positive. Well, when x is less than -2 is when it's negative. So right away, that one's wrong. Awesome. See how we did it ourselves. I encourage you, go this route. It will help you very well if you can. All right. We're getting close to done. Fill in the blanks using the available answer choices. A root of the equation 3x minus 8 equals 13. Well, a root just means we solve it, right? So we're going to solve 3x minus 8 equals 13. Add 8 to both sides. 3x equals 21. Divide by 3. And we get that x equals 7. Yes, I need to see all this. That's an answer. Let's put it in there. A root is the answer to an equation. It's also going to be the x-intercept and all that good stuff. Awesome. What do we got? Ronald buys fresh fruit from a stand. Apples cost $5 per pound and peaches cost $6 per pound. He has $60 to spend. The table shows the function relating the number of pounds of apples X and the number of pounds of peaches Y Ronald could purchase. Okay, let's do this. So the blank intercept shows that if Ronald buys only apples, so if he's buying only apples, apples are X, that means he's going to have an X value and a 0 Y value. What is that? That is an x-intercept. And he can buy how many pounds? Well, if he only buys apples where Y equals 0, that means he can buy 12 pounds of apples. Awesome. The blank, well, clearly it's going to be y-intercept, shows that if Ronald buys only peaches, and that's the y-intercept, that's because he's not buying any apples, he's just getting y. So let's look where x is 0. And what is y going to be? He can buy 10 pounds of peaches. That's it. Ooh, I already told you what kind of a function this is. Anytime you see that v, it's going to be an absolute value. But let's see what it's asking us. The blank represents a function. The graph, let's see, does it pass the vertical line test? Yep, everywhere we go, does. That was one of our choices up here. It is, what kind of a function? Is it linear? Nope, it's nonlinear. It's two lines meeting, but that means it's nonlinear, right? It is a blank graph. Is it continuous or discrete? Well, there's no breaks in it, so it is continuous. That is symmetric in the line x equals, where's the line of symmetry? Well, if this is the origin right here, we see that if I were to draw a line at x equals -1, I could fold this over on itself so it's x equals -1. Perfect. And last but not least, the graph of the function is shown. Use the graph to describe the line of symmetry, if any, on the function. Is there anywhere I can put a line that would make this fold on itself? Nope, there's not. A lot of our brains want to say like right there, but again, if I folded it over, it'd be like this, right? So that's not a line of symmetry. No line of symmetry. Last page. This team test looked a lot longer than it was. It just had a lot of problems that were kind of big. You know what I'm saying? So match the description of the end behavior of the graph with the graph of the function it describes. So as x increases, y increases. Which ones are like that? Well, as x goes up here, y is going down, so not the first graph. As x goes up, y is increasing. That works. As x goes up, y is increasing. So it's either of these two. As x decreases, y decreases. Well, as x gets smaller on this graph, we know it's only these two. And as x gets smaller, y is still going up, so it's not that one. As x gets smaller, y is going down. It's this one. So our first match goes here. As x increases, y increases. Well, we know it's not that one already, so we know it's this one. But let's finish it off and prove it. As x decreases, y still increases. Still this one. Okay. And then clearly we're left with that. That's called problem solving. But let's see why as x increases, y decreases. Yep. And as x decreases, y decreases. Yep. Okay. Remember, we're only looking at the ends on end behavior. Select all the points that are relative minima of the function. Remember, relative minima are the valleys. We see valleys at D and E. That's it. And that is this test. So, study this. Write notes. Peace out. Bye, guys.